Hello everyone, JavaMentor.net here. In today's video, let's learn how JPA models inheritance. Today's video will be a little bit different because there is one great article on the internet that covers the topic that we are learning about today. So this Wikibooks Java Persistence Inheritance article really covers everything, so I will not write code and run the application to check everything out. You can do that. But I will just scroll through this article and I will briefly talk about important things. So, I should mention that in this tutorial, all annotations are coming from the same Jakarta.persistence package. We are working with JPA, so all annotations are from that package. What is our problem? So let's say that we have some project class, which is our entity, and we have two classes that are extending the project, large project and small project. How to map this to our database, to our SQL tables? Well, there are few strategies. The simplest strategy is to say, this is the project, oh hey, I have large project and small project, but put all objects of all of those three classes inside the same table. So you have single table for all of those subclasses. And you will see that this is how your SQL looks like. So that table has ID, project type, name, and budget. Of course, if you're putting different objects inside the same table, you need to discriminate them somehow. So here you're saying, okay, discriminator value is L, which means that in project type, row with L is object of type large project. And here you need to mention which column is discriminator column. This is standard JPA entity annotation. You need to put this inheritance annotation, nothing weird. You need to specify which column is discriminator column. This is also a standard JPA annotation, which is telling you what is the name of the table in the database. I mean, if your class name match the database name, this is redundant, but it's okay. ID annotation, we saw that one already. We didn't saw this one already, and the point of this one is, while we are here, just not a skip, I want to explain is that you don't want manually to set ID for the project, but you will create an object of the project class without ID when you want to insert project into the database, and then database will generate one ID for you using some identity strategy. Okay, so we explained this single table strategy. Basically, objects of all subclasses are going to the same table. There is one column which is called project type. That column is discriminator column. And the good thing about this article is that there are common problems. So with this single table strategy, common problem is if you're trying to map some old database schema, there might be no class discriminator column. You can check it out here how to solve that. Also, for example, you can see for this small project, budget is null because small project doesn't have budget. Budget is field of the large project. So for the fields which does not exist in small project, you're putting null. And for that reason, you cannot enforce non-nullable attributes. Okay, the next strategy is joined multiple table inheritance. So for the same projects, large project and small project, this is how your annotation should look like. So you change the strategy here. You need again discriminator column. But now your database schema looks a little bit different. So you have here project, you have all fields from the project class, but then you have two um, additional tables, small project and large project. So from the Java, when you want to fetch a small project object, you need to join project and small project. When you want to fetch large project object, you need to join project and large project. And that joins are slow, you should know that. So that is mentioned as one of the main disadvantages. Poor query performance. You need to perform joins. Even worse is if you're trying to fetch all projects. So not you don't want to say give me large projects, but you want to say give me projects. Then you need to fire multiple queries. Query number one will be give me project join small project, and query number two is give me project join large project. So that's the reason why you have poor query performance, and it's mentioned here that querying the root is even more difficult. Okay, another problem would be you don't want a table for every subclass. It's explained in which cases that happens, and also the same problem as in previous strategy. For old schemas, you might not have discriminator column. Okay, third strategy is table per class. It's mentioned here, table per class inheritance. Allow inheritance to be used in the object model. So you have inheritance in your Java, but that inheritance does not exist in data model. So this is the model in the database. You just have small project and large project tables. There is no project table, so you don't see inheritance in the database. Of course, again, there are some problems, mainly where you're trying to fetch all projects, so not only small or large projects, but generally all projects where you're trying to query base table. You will have issues, and also you will have some problems with ordering and joins. How to order rows from different tables. That's very weird. So you can read about that here. And the last strategy is mapped superclasses. This strategy is very similar to the previous one, to this table per class inheritance. The only difference is that with this mapped superclass, you cannot query base class. And you usually want to use this mapped superclass when multiple classes share the same fields that are in the base class, but you never want to query base class. So in our case, you would like to use mapped superclass if your both large project and small project extend the same ID and name, but you never want to query all projects. You always want to query only large projects or small projects. Don't be too afraid if you don't understand when to use which strategy. It's okay for you to, for now, use the simplest strategy, which is single table inheritance, and then you will realize, of course, go through this document, learn about pros and cons, but when you gain more experience, you'll realize which strategy should be used in which case. Of course, for this mapped superclass, there are also common problems. As I told you, cannot query, persist, or have relationships. And subclasses does not want to inherit mappings, which means if you have some subclass that doesn't want to inherit this ID and name, then that's a problem. And that's basically how JPA handles inheritance. Just go through this document. It's on Wikibooks. It's called Java Persistence/Inheritance. And this is everything that you should know about JPA and modeling inheritance. In the next video, let's learn about embeddables.